At this time, I'd like to introduce our presenter, Richard Roberts. Richard is Industry Affairs Manager for System Sensor and Honeywell Life Safety. Richard, take it away.
Thank you, David. I'd like to thank everyone for taking time from their busy schedules to attend today's informative presentation. Even though this is being presented by System Sensor, it is not a product sales pitch. Rather, it's an unbiased presentation that provides answers to several frequently asked questions and code-related requirements. The agenda for today will be to cover 3 important facts about carbon monoxide gas and CO detection. We'll review several key requirements in NFPA 720 relating to a systems-based approach to CO detection. Now, when I refer to a systems-based approach, I mean a system where CO detectors listed as complying with UL 2075 are connected to a control unit, not multiple station CO alarms listed as complying with UL 2034. And finally, we'll look at several states that have added requirements recently for the installation of CO detection. So let's get started. First, we'll talk about the alarm thresholds of CO alarms and detectors. That's because there's a lot of misinformation about the topic. Many people say by the time a CO detection device goes off, people are already poisoned, or that CO alarms are prone to false alarms because they are too sensitive. Actually, both statements are false. Let's take a look at the initial thresholds and why they were changed several years ago. This will help everyone to understand why some people are confused about the current requirements. So when first introduced in the late 1980s, CO detection devices were adequate, but they easily alarmed when exposed to long-term low levels of carbon monoxide. The one incident that gained considerable media attention, and is still talked about today, occurred in December of 1994 when the Chicago Fire Department responded to over 1,800 false alarms in a 24-hour period. This was due to a thermal weather inversion that trapped cold air under a layer of hot air, which prevented pollutants like automobile exhaust to escape into the atmosphere. Of course, CO is one of the main byproducts of found in car exhaust. The CO concentrations during this event were not dangerous, but they were high enough and long enough to cause CO alarms to activate. Needless to say, emergency first responders, UL, the industry were very concerned about the false alarm activations that occurred as a result of this incident and other activations that may have been caused by more short-term transient CO levels. Therefore, in 1998, UL and other stakeholders embarked on a project to update the alarm thresholds by adding several false alarm requirements to prevent these unwanted alarm activations. This important change requires no alarm but below 30 ppm until after 30 days, and no alarm at 70 ppm until after an hour. Now, the 30 ppm requirement is to protect against alarm activations due to long-term concentrations, such as from weather inversions. And the 70 ppm requirement is to protect against short-term concentrations that are caused, let's say, by a water heater or a furnace starting up. Now, as you can see, there are 2 product standards covering CO detection devices. The first standard is UL 2034, which covers single and multiple station alarms. These devices are self-contained and not intended to be connected to a control unit. The second standard is UL 2075, and it's the standard for detectors that are designed and listed to be connected to a control unit, such as a commercial fire alarm panel or a household combo fire security control unit. Even though there are 2 product standards, they both have the same alarm thresholds. So what are the current alarm thresholds? The first threshold is not actually an alarm set point. Rather, it's designed so the device will not alarm at 30 ppm until after 30 days. As mentioned in the previous slide, this requirement is to protect against alarm activations due to long-term low levels of CO. The first alarm threshold is designed so the CO device will activate at 70 ppm between 1 and 4 hours. The second alarm threshold is set so the CO device will activate at 150 ppm between 10 and 50 minutes. The last alarm threshold is designed so the device will activate at 400 ppm between 4 and 15 minutes. It's also important to point out the alarm thresholds that we just mentioned are intended to respond to the presence of carbon monoxide gas before a healthy adult loses their ability to react to dangers of carbon monoxide. Now let's switch gears and take a look at the various principles of CO detection. Both alarms and detectors monitor the amount of CO in the air over a specific time period, but they are really distinguished by their sensing technologies. There are three basic types of CO sensors used in today's marketplace. They are biomimetic, metal oxide semiconductor, and electrochemical sensors. Now, regardless of the sensing technology, all sensors used in single and multiple station alarms and system-connected detectors have a limited life. The lifespan ranges anywhere from 6 to 10 years, and that's depending on the sensing technology used and the manufacturer of the actual alarm or detector. The first technology we'll discuss is biomimetic. Now, biomimetic sensors really mimic how the human body reacts to carbon monoxide. Therefore, before we start explaining how these types of sensors operate, it's important to understand how CO reacts within the human body. Through the normal process of respiration, oxygen enters the lungs and is transported by hemoglobin that's found in the blood to various organs and tissues in the body, such as the heart and the brain. When CO is inhaled, it enters the bloodstream and attaches to hemoglobin, forming the carboxyhemoglobin molecule. Now, because CO is absorbed in the bloodstream over 200 times faster than oxygen, and it forms a stronger bond than oxygen, it reduces the ability of the blood to carry oxygen to the body's vital organs. So basically, people die from asphyxiation when they are exposed to high concentrations of CO gas over a long period of time. So getting back to the biomimetic sensor, they monitor the amount of infrared light that is passed through a disc of synthetic hemoglobin. The disc darkens in the presence of carbon monoxide. As CO concentrations increase, the light is absorbed, which then triggers an alarm. With metal oxide semiconductor technology, or it's more commonly referred to as MOS sensors, a tin dioxide semiconductor is heated by an electric current at regular intervals. When the tin dioxide reaches its operating temperature, it's capable of changing its resistance in the presence of carbon monoxide. Once the resistance reaches its predetermined threshold or thresholds, it triggers an alarm condition. Lastly, electrochemical sensors use an electrode and acid combination to promote a reaction between CO and oxygen in the air. This produces an electric current. When sufficient CO is present in the air and the current reaches beyond its specific predetermined thresholds, it will trigger an alarm signal. Now, as with any products or technologies, there are advantages and some drawbacks. And this is no different with each of the sensing technologies we just discussed. Biomimetic sensors require relatively low current draw to operate. However, these types of sensors have a long recovery time relative to the other two sensors, after an alarm activation. It could take as long as 15 or 20 minutes to recover from an alarm. MOS sensors have a long lifespan and recover quickly after an alarm activation. However, MOS sensors require a higher current draw than biomimetic or electrochemical sensors because it uses an electric current to heat the semiconductor. And lastly, electrochemical sensors have a relatively low current draw and they recover very quickly after an alarm activation. However, they may be susceptible to false alarms in the presence of very high concentrations of ammonia, and this is typically used in household products such as glass cleaners. Therefore, it's recommended to dampen a cloth with water to clean the housing of a CO alarm or detector instead of using a cloth that's saturated with ammonia. As mentioned a few slides ago, all CO sensors that are used in alarm and detectors have a limited life. Because of that, UL 2034 requires all alarms to indicate an audible end-of-life signal, and it has to be different from the alarm signal. UL 2075 requires all detectors to provide a means to send the sensor's end-of-life signal to the control unit. Now, for the 2012 edition of NFPA 720, that's the installation standard for carbon monoxide detection warning equipment, they added the following requirements to the standard. First, replace all alarms and detectors after the EOL, or the end-of-life signal, is activated. Secondly, replace combination smoke CO alarms after the end-of-life signal is activated, or 10 years from the date of manufacture, whichever comes first. Now let's switch gears and look at the placement requirements that are found in NFPA 720. And first we'll look at is for CO alarms and household CO detection systems. Section 9411 requires CO detection to be installed outside of each separate dwelling unit's sleeping area in the immediate vicinity of bedrooms, on every occupiable level of a dwelling unit, including basements, but excluding attics and crawl spaces, and other locations where required by applicable laws, codes, or standards. Also, each alarm or detector shall be located on the wall or ceiling. Now, I'd like to point out that the IRC, that's the International Residential Code, and many state laws, they don't require CO devices to be installed on every level. Rather, many of them require CO detection to be installed in or near the bedroom. Therefore, it's always important to check with your local AHJ before designing or installing your CO alarms or detectors. Now, even though NFPA 720 requires a CO device to be installed outside of each bedroom, it's very important for the sound level to penetrate through closed doors into the bedroom to awaken people who are sleeping. The CO alarm or detector in the hallway may not be loud enough to wake someone who is sleeping because of a window air conditioner or a TV. This situation may require an additional device to be installed within the bedroom. Now, to make sure the sound level is high enough to wake people sleeping, Section 6441 of NFPA 720 requires the audible alarm signal to produce a sound level of at least 15 dB above the average ambient sound level, or 5 dB above the maximum sound level, or finally a sound level of at least 75 dB that's measured at the pillow. Now, looking at Section 55531, it requires CO detectors to be installed on the ceiling in the same room as a permanently installed fuel-burning appliance, centrally located on every occupiable level and in every HVAC zone of the building. Now, the reason CO detectors are required to be located on the ceiling above permanently installed fuel-burning appliances is because of the buoyancy of the heated combustion gases from the fuel burning appliance as compared to normal ambient temperatures. Now, a frequently asked question I get is, what is the weight of CO relative to the air? Some people say that CO devices should be installed near the floor because CO is heavier than air, while others say it is lighter than air, which means the CO device needs to be installed on the ceiling. Now, the simple fact is the molecular weight of CO is virtually identical to air. Specifically, the molecular weight of CO is 28 grams per mole, whereas the molecular weight of air is approximately 29 grams per mole. Therefore, that's the reason why in chapter 9, a few slides ago that we talked about, CO alarms and detectors are permitted to be installed on the wall or the ceiling. Another frequently asked question is how CO disperses within a building. This question is best answered by a Fire Protection Research Foundation study that was concluded in 2007 by Hughes and Associates. This study was requested by the NFPA 720 Technical Committee to determine the placement requirements for these devices. The literature review concludes that CO disperses by two major mechanisms. First, by forced convection from mechanical ventilation systems. Secondly, from natural forces when mechanical ventilation systems are not present. Now, several examples of natural forces include solar heating through walls and windows, doors opening and closing, and occupant movement. The study also goes on to conclude that whenever a ventilation system is present and operating in most modern buildings, it will dominate the flow of CO in the building, and it will result in a very well-stirred environment within the ventilation zone. Okay, David, it looks like we're ready for our first poll question.
Very good, Richard. We do have a poll question ready, and we also have one question in queue, so we'll answer that during our poll question. If you could, in a moment or so, you'll see a poll question that'll pop up on your slide on your screen there. If you could go ahead and answer it. And basically the question is, what are the factors that contribute to CO poisoning? Is it that length of time exposed, maybe the type of appliance, concentration of gases, or the season it occurs? If you could go ahead and answer that, we would appreciate if most or all of you could go ahead and vote on that poll question, and then we'll obviously publish the results here in a few moments. Richard, the question that comes in is there a specific definition of that immediate vicinity ruling? Does it have to be, say, a certain distance from the bedrooms? So how do you define immediate vicinity?
That is an excellent question and one that I frequently get. And as you can see, the requirement in the immediate vicinity is really very vague, and it's not very good code language. It really gets back to what I mentioned a few slides ago, and that is you really need to make sure that if you install a CO alarm or detector in the hallway outside of the bedroom or bedrooms, that with that bedroom door closed, that you're able to get 75 dB at the pillow to wake people up. So, you know, if you really have a large house, say you have 4 bedrooms on the second floor, and you got that common hallway between all the bedrooms, and especially in a master bedroom, which could be quite large, you may require an additional alarm within that bedroom. But I guess the short answer to the question is, in the immediate vicinity, it's really not a defined term. There's no text or language in there that says immediate vicinity is within 10 feet or 5 feet. It's a very vague term.
Okay. All right. I did take the poll question down, so thank you to the 82% of you that did vote in the poll question. We would encourage everyone to vote in those. There's 2 more left. So what are the factors that contribute to CO? A little bit of a trick question here. The right answers here are time exposed, as Richard talked about, and also that concentration of gas. The type of an appliance, while it can be a contributing factor, if it's a gas appliance versus an electric appliance, is not the correct answer. And then the season it occurs, while there may be more significant use of those types of appliances, say in the fall or winter, that's also not the right answer. So it's time exposed and concentration of gases. Richard, let me go ahead and take that poll question down, and we'll get back to your presentation.
Okay, thank you, David. All right, now let's turn our attention to several key provisions in NFPA 720 that deal with a systems-based approach to CO detection. One of the first decisions for engineers or system designers is whether to use a dedicated CO control unit or connect the CO detectors to a fire alarm or security control unit. NFPA 720 permits a CO detection system to operate as a standalone system, or it can be part of a combination system. In any case, they shall be arranged to operate as a single system. Most installations, though, will connect the CO detectors to a fire alarm control panel or a household fire security panel in order to keep the infrastructure simple and to avoid increasing costs. However, there are several key important factors to keep in mind when using a combination system. If a CO detection system is combined with a fire or security control unit, all CO subsystems shall be, and all subsystems, fire, CO, shall be capable of concurrent full load operation without degrading the overall system performance. The non-CO detection system shall not interfere with the required operation of the CO detection system. Also, the CO alarm signals, that's the audible alarm signals, shall be distinctive, clearly recognizable, and take priority over signals associated with property protection. Of course, a fire alarm signal will usually, almost always, take priority over an audible CO alarm signal. Now, it's also important to point out that the Temp 4 CO audible alarm signal is a notification signal only. It's not an evacuation signal like the Temp 3 fire alarm signal. Many people get that confused as well, but it's not a building-wide evacuation signal. It's only a notification signal. Also, if the CO detection system is combined with a fire alarm system, the secondary power requirement shall comply with both NFPA 720 and NFPA 72. Now, as it relates to occupant notification, Chapter 6, which is the notification appliance chapter, does not require the installation of CO notification appliances or specified where they're required. Rather, the chapter intentionally gives latitude to AHJs or system designers to decide whether or not to install separate CO notification appliances throughout the building. Essentially, Chapter 6 permits occupant notification to be selective. For example, a building code may require a horn to be installed in the room where the fuel burning appliance is located, or they may require a separate horn or strobe to be located at a remote desk or room. Now, for most commercial sleeping occupancies, the integral sounder of a system-connected CO detector may be sufficient for notifying building occupants. Let me explain. In accordance with 55622, where CO alarm signals are transmitted to a constantly attended on-site or off-premise location, occupant notification is permitted to be limited to the notification zone where the CO signal originated. So what is NFPA 720's definition of a notification zone? 55632 says the boundaries of a notification zone shall be the area where the CO alarm signal originated, or other signaling zones in accordance with the building's emergency response plan. Now, the emergency response plan might specify occupant notification only in the area of initiation, at a control panel, or at a constantly attended on-site location. In other words, whole building evacuation might not be specified in the emergency response plan. Now, for example, take a 10-story hotel. If that CO detector goes off in the boiler room on the first floor, you don't necessarily want to evacuate the whole building initially. If that CO alarm signal goes back to a constantly attended on-site location with, let's say, the registration desk, many system designers or building codes may require that that's only where that CO alarm, audible alarm signal goes. However, if notification appliances are required by the AHJ or local building code, Chapter 6 has specific requirements and permits using the same notification appliance for CO and fire alarm signaling. Now, this is intended to keep the system infrastructure simple and to avoid increasing cost. If a notification appliance is used for CO and fire, it shall not have the word fire or any fire symbol on the appliance. And don't forget, the audible CO alarm signal must be a temp 4 tone, while the fire alarm signal must be a temp 3 tone. Therefore, if the same horn is used for CO and fire signaling, it must produce a temp 4 signal for CO activation and a temp 3 signal for a fire alarm activation. Well, Dave, we're ready for another poll question.
Very good, Richard, and I'll serve that up here in just a moment. If you do have any questions for Richard, go ahead and use the chat feature or the Ask a Question feature on GoToWebinar, and we do have a couple of questions posted here that we'll get to following the poll. So the next poll question is, where can CO devices be installed according to NFPA 720? So is it outside that sleeping area, the ceiling, or the wall? Really check all that applies. So if you could go ahead and register in on our poll question there, and then we'll get to some of the questions here. Richard, the first question is what is the common sensor that's available through CO devices sold through security distribution?
Actually, I'm not the all-knowing expert on competitive product, but I think that it pretty much covers the full gamut. Metal oxide or MOS sensors, biomimetic, and electrochemical sensors. However, I think that the electrochemical sensor is probably the most widely used.
And what then they've asked specifically about the system sensor CO1224T or TR. Is that which type is that?
That is the electrochemical sensor.
Okay, all right. Next question, Richard, while people are coming in to vote. The gentleman asks about installation of CO detectors in industrial facilities and if the code has some specific guidelines with regards to either the type or location of CO detector installation.
Excellent question, and that's another one that I frequently get. And you really got to look at the scope of NFPA 720. And the scope of this standard only covers CO detection for life safety purposes. It does not cover CO detection or gas detection that's intended to monitor and control indoor air quality. And when I say monitoring and controlling indoor air quality, that could be CO detection that's used in enclosed parking garages or in warehouses where you may have trucks and stuff like that, or cars idling. There are separate products that are intended to be installed in these types of industrial applications. I know that Honeywell Analytics has a product that monitors for that type of gas detection. You can go to the Honeywell site and look at that. So, but there are other manufacturers too, just to be fair. Yep,
and he makes a comment here that he also apparently does work in offshore oil platforms, and he's used our CO detectors in the sleeping spaces that the men and women use in those offshore oil platforms. But he's wondering about more of the industrial application, and I think probably your recommendation of a company like Honeywell Analytics is good there as well, isn't it?
Exactly, and also once you start talking about industrial applications, it may not be in conditioned spaces or rooms, and there are specific environmental specifications that NFPA 720, UL 2034, and UL 2075 specify that these need to be installed in. In other words, you can't be installing these devices where the temperature goes down to below zero, or if it's way above, let's say 100 to 120 degree F. And there's also relative humidity considerations as well. So once you get into these environmental conditions, it's probably outside of the specifications of the system sensor CO1224T or TR.
Yep, good. Last question for this session, or this poll session, Richard. They're wondering about a minimum number of CO detectors required or a maximum number that's allowed on a single system in a residential installation.
Good question. And if you look at the CO1224T and TR, and I think most other manufacturers as well, it's essentially, it operates almost like a 4-wire smoke detector. In other words, you have an initiating device circuit and then you have a separate power circuit. So you connect that power circuit to the control unit, and whatever the auxiliary power output of that control panel is, that would determine how many of these CO detectors you could install on a control unit. And in terms of the zoning of the devices, or how many you could put on an initiating device circuit, that really depends on how you want to break the occupancy or the building up. Do you want just one CO alarm indication for a dwelling unit, or do you want to have it per floor? Same holds true if you're doing it in a commercial occupancy, such as a hotel. You may have several different mechanical rooms where you install your CO detection in, and you may want to indicate each one of those mechanical rooms at the control unit or back to the supervising station.
Okay, very good. Just to recap the poll questions and the answers here. So where can CO devices be installed? The real answer is in all of those locations. You can be outside a sleeping space, on a ceiling, or on a wall. So the correct answer would be all three. Richard, let me go ahead and take that down, and we'll get back to your presentation.
Yeah, just to follow up one thing on the poll question, if you're installing your CO device in a room where there's a fuel-burning appliance, as I mentioned just a minute ago, a mechanical room that has a boiler or a furnace, you really want to install it on the ceiling there, and that's due to the buoyancy of the combustion gases being produced by the fuel-burning appliance. So, but outside of those areas, yes, you can install it on the wall or the ceiling. Okay, let's get back to the presentation. The next several slides will provide an overview of the legislative and the building code requirements for CO detection. Now this map is a nice illustration of the 39 states that have laws or regulations requiring the installation of CO detection. The states colored in blue have some form of mandate to install CO detection. Now most of them cover 1- and 2-family dwellings and townhomes not more than 3 stories. But more and more often, commercial sleeping occupancies, such as hotels, dormitories, apartment buildings, hospitals, nursing homes, and assisted living facilities are required to install CO detection. And speaking of those commercial sleeping occupancies, this map shows the 17 states, colored in orange, that have some form of mandate to install CO detection. Now, what I find really interesting from this map and the previous one is how many states have adopted regulations or laws in the last several years. For example, if you go back to the December 2009 System Sensor CO webinar, at that time we reported 26 states as having some form of mandate to install CO detection. So as you can see, over the last few years, it's really increased by 13 states. And with the CO detection requirements firmly in the model building codes, this trend will only continue within the next 3 to 5 years. Didn't mention it in this webinar. In one of the System Sensor archived webinars, we do go over the new CO detection requirements that's in the International Building Code, International Fire Code, and NFPA 101, and that's the life safety occupancies. Now, if you want details on the specific state legislation or code, you can go to the System Sensor website, and that would be systemsensor.com/CO. There you'll be able to download the actual law or regulation. And we try very hard to keep that database up to date and current, but it's always a good idea to contact your local authority as well. Now let's look at several bills that have been signed into law this year. In April, Maryland Governor Martin O'Malley signed Bill SB 173 into law. The bill requires the installation of a CO detector in newly constructed or remodeled public schools that contain a fuel-burning appliance. Now, the act will take effect in October of this year and requires the signal from a CO detector to be automatically transmitted to a supervising station or a constantly attended on-site location. Now, Maryland is the second state to require CO detection in public schools. In July of last year, Connecticut signed a bill into law requiring CO detection in newly constructed and existing public or non-public school buildings. Now, this legislation became effective in January of this year. In March, Maine Governor Paul LePage signed Bill LD 1744 into law. This bill expands Maine's existing law for requiring CO detection in newly constructed 1- and 2-family dwellings and rental dwellings to require the installation of CO detection in newly constructed or renovated hotels, motels, inns, fraternity houses, sorority houses, or dormitories. The effective date of this act is actually this month. Now, recently, several states updated their model building codes. First, South Carolina Building Codes Council updated their residential and building code to require CO detection in newly constructed 1- and 2-family dwellings, townhomes not more than 3 stories, hotels, apartment buildings, and dormitories which contain a fuel-burning appliance or an attached garage. Ohio, the Ohio Department of Building Standards adopted the 2009 edition of the International Residential Code. Now that means CO detection will be required in newly constructed 1- and 2-family dwellings and townhomes not more than 3 stories, and the effective date will be January of 2013. Okay, David, I think we're ready for our last poll question, and it sort of gets to my favorite part of the webinar, and that is answering as many questions as possible as time allows.
You bet. So we'll get to our last poll question here and then do submit any questions that you do have. We do have a few minutes remaining in the time reserved for this webinar. So the question is, does a combination smoke CO detector use the same audible alarm signal, yes or no? So Richard talked a little bit about temp 3 and temp 4. That's a hint, by the way, but if you can answer yes or no to this question, and then we'll post those responses. So Richard, the first question is, It's maybe more of an opinion, but how can the average person determine the difference between a Temp 3 and a Temp 4 code? Let's say I'm visiting a hotel complex for the first time. They have a CO detector and a smoke detector side by side. How will I know the difference?
Excellent question, and that's actually a topic of hot debate within the codes and standards community right now. And the unfortunate and the simple answer is, the typical consumer or citizen will not know the difference between a Temp 3 and a Temp 4 signal. And, sometimes in the home, for example, you may want to have a voice driver when you use your system-connected CO detectors there. And then that way, it'll, in addition to the Temp 3, Temp 4 audible tone, you'll have a voice message that will say, fire alarm or carbon monoxide alarm. But I think the industry really needs to do a better job at trying to educate consumers on the difference between the Temp 3 and the Temp 4 audible alarm signal.
Okay. All right. Next question is about spacing requirements for CO detectors. Are they similar to spacing requirements for smoke detectors? And then the follow-up question to that is, if you have a much larger space, let's say a big open atrium or whatever that might be, would that require more than one detector per level?
Excellent question, and that's actually one that I get, quite a few questions on. And the short answer is CO detection devices do not have spacing requirements similar to smoke detection devices. As most everyone knows, smoke detection devices, we have 30 by 30 foot spacing, 900 square feet. However, as I mentioned in the presentation, CO dispersion really occurs in modern buildings, and as we all know, modern buildings, whether it's 1 and 2 family dwellings or hotels or apartment buildings, convention centers, they have a mechanical HVAC system. And because CO is virtually the same molecular weight as air, and because it's a mechanical ventilation system, it will disperse the carbon monoxide gas very quickly and thoroughly within the building. And I did mention that there is a Fire Protection Research Foundation study that really covers that. So, for example, if you have a large atrium, or if you have a large ballroom in a convention center, theoretically you can only, you would only need one CO detection device in that space. Obviously, it might not hurt to have two, but as I said, because CO is virtually the same molecular weight as air, and because of the HVAC system, it'll mix that CO gas very quickly and evenly with the air within the HVAC zone and within the building. Okay.
All right, I'm posting the poll results here. Does the combination CO smoke detector use the same audible signal? And Richard, 88% are saying no, and I'm guessing that's where that Temp 3 and Temp 4 situation comes into play.
Absolutely.
Good. We'll leave Richard's contact information up there. We will tackle a couple more questions that you have posted, so if you do have any questions, please post them at this time. We're coming to the end of our webinar. Richard, the next question, and one of our attendees is frustrated. He said he's gone to his state fire marshal to try to get an answer and was told that no, their state hasn't even adopted NFPA 720 yet, so there's no standard for this question. And he's actually wondering if there are any hard requirements or even recommended guidelines for the following. How a monitored CO detector is dispatched from a central station. So an alarm comes in, what should that central station do?
That is a very, very good question, and actually that is covered in Chapter 7 of NFPA 720, and that is the off-premise alarm communication chapter for CO detection systems. Now, obviously, if the state has not adopted NFPA 720, that does not mean that you shouldn't follow a national consensus standard. So basically what the Chapter 7 of NFPA 720 says, upon receipt of the CO alarm signal, supervising station personnel shall perform the following actions in the order listed. Where required by the emergency response agency, immediately retransmit the indication of the CO alarm signal to the communication center, and then contact the responsible parties on the contact list. A couple important things to point out here is it says where required by the emergency response agency. First, it doesn't say the fire department. It says the emergency response agency. And that's because, as odd as it seems, in some jurisdictions, they don't want people to call the fire department. They may call the EMS department, or they may call the police department. I would say, and this is my own personal opinion, the vast majority of jurisdictions, these calls will go to the fire department. Secondly, it says where required by the emergency response agency. Some jurisdictions may want the supervising station personnel to first call the dwelling unit, the homeowner, or the building to see what's going on there. Those are two things there. If you want the actual extract out of 720 or more explanation, please feel free to give me a email at the email address that you see there. But NFPA 720 has specific requirements for the supervising station personnel on what to do when they receive the CO alarm signal.
Very good, very good. Next question I can tackle. They're asking if they're going to get some kind of certificate of attendance for attending this webinar today. Yes, we will. All of those that attended the webinar will receive that in the mail. So I can answer that one. Next question, Richard, little involved here, but they're saying that the fire marshal didn't like CO detectors on the fire alarm system because of frequent false alarms, and he was under the impression that CO detectors went off at 30 parts per million. And he said, listening to your descriptions, I'm wondering if this was a very old system, and were past codes in fact set at 30 parts per million?
As I addressed in today's presentation, the early UL 2034 alarm thresholds were different than what the current ones are. And I think I said that they were changed in 1998. And I think the first alarm threshold may have been at 70 or 30 ppm, but now there are new thresholds in there that are really designed to minimize to the greatest extent possible unwanted alarm activations. And as I said, no alarm at 30 ppm until after 30 days, and then at 70 ppm it has to go into alarm between 1 and 4 hours. It sounds like this AHJ still remembers the problems back from that temperature weather inversion in Chicago, where there was over 1,800 false alarms in a 24-hour period. And that was the reason why I brought that up in today's presentation, because many people say, they're too sensitive, they frequent false alarms. So the newer versions of CO alarms and detectors should not be as prone to false alarms as what the earlier versions were.
Yep. Hey, and Richard, as a Chicago resident myself, we do have long memories. We're still talking about those 85 Bears. So, as you know,
the Bears, the Bears.
Exactly. Let's see, Richard. Let's tackle one more question here, and then we'll have to draw this webinar to an end. The question is when you say CO devices can be used in line, what do you mean by that?
In line?
When you say CO devices can be used inline, oops, let me read the rest of it. With fire alarm devices, what do you mean? Is it used on the same circuit, or they thought they heard something about inline?
No, I mean, you really want for a system-connected CO detector, you want that CO detector to be installed on a separate initiating device circuit than any fire alarm device. However, if you're using a horn or a strobe, a separate horn and strobe for CO notification and fire alarm notification, you can use the same device. However, that device cannot have the word fire or any fire symbol on it. But keep in mind, as I also said, that 720 does not require horns and strobes for CO notification to be installed throughout the entire building or occupancy.
Okay, very good. This does draw to...
If you hold on one second, I'm going back to the slide that, I covered this. It basically says that notification appliances used for CO signaling and fire shall not have the word fire or any fire marking on the fire device.
Very good. All right. Well, thank you, Richard. On behalf of System Sensor, I do want to thank you for joining us today, all the attendees that did join in. And as a follow-up, we will be sending you a brief survey in about an hour and would appreciate your help in filling that out. And we do plan to reward one of you that completes the survey with a $50 Target gift card. So thank you again for joining us. This does conclude our webinar. Please have a nice rest of the day.